Let's study the first concept from Unit 1, that is lexical analysis. Lexical analysis is also called as scanning. Lexical analysis is the first phase in compiler design. A lexer takes the modified source code which is written in the form of sentences. It helps you to convert a sequence of characters into a sequence of logical units called as tokens. It removes any extra space or comments written in the source code. Before actually proceeding with lexical analysis, let's consider one statement in English. Here, we can easily recognize that there are three words and one question mark symbol. This is very natural for us as we can recognize the separators, blank and the question mark symbol according to English language. Now let me slightly modify this statement as we can also read this statement. However, it will take some time because separators are not put in proper places. The lexical analysis phase in compiler design deals with recognizing valid tokens in a program. Some of the tokens are keywords, identifiers, and operators. To begin with, let's understand the role of lexical analyzer. The getNext token is a command sent from parser to lexical analyzer. On receiving this command, the lexical analyzer scans the input until it finds the next token. And once it identifies the proper token, it returns that token to the parser. Before proceeding with lexical analysis, we need to understand some terms. These terms are tokens, patterns, and lexeme. I will explain you all these terms by using a simple assignment statement in C. Lexical analysis phase deals with identifying category of each of the input string over here. So if I want to identify category of A in case of programming language is considered as a valid identifier. Is equal to is considered as operator. B is again an identifier, plus is operator, C is identifier, and semicolon is operator. So identifying the constituent units in this programming statement is our tokens. So A is one token, that is identifier is one token, is equal to operator is another token, B that is identifier is third token, plus as operator is the next token, C as identifier is next token, and semicolon as operator. So identifying category of each of these input symbols in this statement is a token. The next term is lexeme, the actual string for which we are finding out the category. Okay, so if you consider this A is one lexeme, is equal to is second lexeme, B is third lexeme, plus is fourth lexeme, C is the next lexeme, and finally we have the semicolon. And the last term is pattern. In order to find the category, that is A is an identifier or is equal to is operator. So somebody must have already defined the rules for identifying this, right? So the rules which are defined in order to identify proper category of each of these components here is patterns. We make use of regular expressions in case of lexical analysis in order to recognize the valid set of tokens. Some of the examples of tokens are given here. So if you encounter sample lexeme in your program, as if, you can write token as reserved keyword, or you can write that token as if directly. Else, comparison operators, if you encounter less than or equal to or not equal to, you can write it as comparison operator. If you encounter lexemes like variable names, pi, score, d2, you can write token found as identifier. For any numbers, if you encounter, you can write the token as number. And finally, for literal. For any identifiers encountered in source program, the information about these identifiers is stored in one data structure called as symbol table. So whenever any symbol is encountered for the first time, say if you consider this statement E is equal to M into C by S, since E is an identifier, its information will be stored in symbol table. Okay, now the information is stored by using some additional information over here, that is identifier. Since E is an identifier, its information will be identifier comma pointer to symbol table entry for E. Now when E is encountered, it is stored. Now if E is encountered somewhere down in your code, you will have to check the symbol table entry. If the entry for E is already present, no need to store information about that symbol again. Okay, that's why we need this pointer. The next symbol here is equal to, so you write it as a sign OP, that is assignment operator, as a token. Then you encounter this multiplication, then you encounter this M, so it is identifier comma pointer to symbol table entry for M. Then you encounter this multiplication symbol, so you write it as mult OP. Then you encounter C is an identifier, so it will be ID comma pointer to symbol table entry for C. Then you encounter division operator, so you write it as div OP. And finally you encounter S, ID comma pointer to symbol table entry for S. Let's talk about design of lexical analyzer generator. So in order to design lexical analyzer for a given source code to recognize set of tokens, we have one tool called as Lex, L-E-X, or also called as Flex tool. Okay, it's a Unix utility, so you can easily run it in Linux or Ubuntu. So the basis for this lexical analyzer, that is that Lex tool, has got three components. So we have something called as input buffering, then we'll shall study about regular expression and finite automata. Input buffering is required in order to store the input string or the input code which is given, for which we are trying to find the tokens. Set of regular expressions are required in order to define rules in order to recognize the tokens. And finally, these regular expressions are converted to finite automata, which becomes easier for processing. Let's study details of this tool in the next lecture. References for this presentation, I have referred to textbook, that is AOL Ullman on compiler design. Thank you and happy learning.